Welcome to this explainer. Okay, today we are tackling a massive, incredibly urgent question that sits right at the intersection of technology, economics, and honestly, our planet's future. The big question is, can we simply recycle our way out of our growing e-waste problem? It's something a lot of us are wondering about as we upgrade our phones and laptops year after year. But as you'll see, the answer is a lot more complex and a whole lot more fascinating than a simple yes or no. Okay, let's dive into this. The physical reality of the global e-waste crisis looks exactly like a giant, overflowing mountain of discarded tech. Currently, less than a quarter of all global e-waste is formally recycled. Think about that for a second. That means the vast majority of our discarded technology is either ending up in landfills, being thrown into incinerators, or, just sitting tucked away in our closets. We are quite literally building mountains out of yesterday's cutting-edge tech. Just to make sure we're all on exactly the same page, let's quickly define what we mean today. E-waste is basically any discarded item that runs on electricity or batteries. If it has a plug or takes a charge and you throw it away, or let's be real, shove it into that notorious junk drawer of tangled cords we all have, it becomes e-waste. To answer our main question, here is our roadmap for today. First, the e-waste crisis. Next, the ticking mineral clock. Then, the circular economy solution, followed by a 4-phase roadmap. And finally, we'll look at some futuristic high-tech solutions. All right, let's kick things off with part 1, the e-waste crisis. So get this, there's a massive 40 to 50 times multiplier at play here. Smartphones contain concentrations of gold, silver, copper, and rare earth elements that are exponentially richer than the raw underground ore we are currently mining. It's wild. By throwing away electronics, we are literally burying the exact high-value materials we desperately need to build our future devices. We are essentially treating a gold mine like it's a garbage dump. Which brings us to part 2, the ticking mineral clock. Now, what's really interesting about this slide is the sheer speed at which we're running out of runway. Look at these timelines. For indium and gallium, which we absolutely need for touchscreens and advanced chips, we only have about 20 to 30 years left of known economic reserves. Lithium and cobalt, the literal lifeblood of our batteries, they face severe structural shortfalls in just 15 to 30 years. Even copper, the absolute backbone of data centers and power grids, is looking at a 50 to 60-year timeline before supply deficits really start to bite. If our current consumption and e-waste trends continue like this, we're heading towards severe structural shortages within our own lifetimes. No joke. So, how do we fix it? Enter part 3, the circular economy solution. This shift from linear to circular is the real pivot point of our whole explainer. Just look at how these timelines change when we introduce a circular economy that combines repair, urban mining, and high-yield recycling. We can actually reduce our total cumulative demand for virgin minerals by up to 58% by the year 2050. Indium jumps from a 20-year crisis to a 100-year buffer. Lithium extends up to 120 years. Copper pushes way out to over 2 centuries. Mathematically, circular strategies extend mineral availability from mere decades to centuries. For many of these elements, the whole concept of sudden depletion virtually vanishes. But obviously, getting there isn't going to be a walk in the park. We face 5 major roadblocks right now. First, glued together tech. Modern laptops and phones just aren't built to be opened anymore. They're literally glued and soldered shut. Second, there is an economic mismatch. Subsidized virgin mining is still artificially way cheaper than complex urban recycling. Third, the hibernation deficit. Honestly, the biggest failure isn't always the recycling plant, it's that our old phones sit in our drawers for years. Fourth, metallurgical complexity. A single modern microchip contains up to 60 different microscopic elements bonded together. Separating them is an absolute metallurgical nightmare. And fifth, we have a severe lack of enforceable global policy. Moving right along to part 4, a 4-phase roadmap. Overcoming those roadblocks requires a massive 4-phase transition. Phase 1 is structural policy. This means legislating universal extended producer responsibility and comprehensive right to repair laws so you can actually fix your stuff. Phase 2 is a design overhaul. We're talking moving to modular assembly, think screws instead of glue, and shifting to hardware as a service, where companies basically lease tech to you and take it back at the end of its life. Phase 3 focuses on infrastructure, formalizing global take-back networks and finally banning international e-waste dumping. And Phase 4, that scales advanced tech, using highly efficient chemical recycling and deploying computer vision and robotic arms for rapid automated disassembly. Ultimately, manufacturers have got to pivot. They need to view their products simply as temporary packages for high-value atomic assets. And finally, part 5, futuristic high-tech solutions. Now, implementing that circular roadmap buys us centuries, which is great, but we do eventually hit physical limits. The first wall we run into is the 5% rule of thermodynamic loss. You see, no recovery process is 100% efficient. With current recycling, a small amount of material is always lost to microabrasion or chemical inefficiency. When you combine that constant 5% loss with the fact that global tech demand is growing rapidly, you realize that recycling 100% of yesterday's hardware still won't build 100% of tomorrow's devices. So the circular economy buys us invaluable time, but it isn't literally infinite. To break that boundary, physics and theoretical engineering offer a few massive, mind-bending shifts. The first is atomically precise manufacturing. Just imagine using microscopic molecular assemblers, essentially nanobots, to disassemble a device at the absolute atomic level and then reassemble it into a brand new product. At atomic precision, that 5% entropy loss drops to near zero. The existing global pool of atoms we have above ground suddenly becomes a fixed, permanently reusable inventory. The second shift is scaling our horizons entirely with off-world harvesting. If Earth's terrestrial inventory is a finite bucket, our solar system is an ocean. Get this. A single 1-kilometer metallic asteroid can contain more platinum, nickel, cobalt, and gold than humanity has mined in all of recorded history. By deploying automated robotic extraction to the main asteroid belt, we effectively render Earth's resource scarcity problem totally obsolete. The third concept is nuclear transmutation. Guys, this is the literal realization of alchemy. Through particle accelerators, we can add or strip protons and neutrons to actually synthesize scarce elements from incredibly common ones. We can literally create gold from mercury today in accelerators. It just costs trillions of dollars per gram right now because of the insane energy required. But if humanity achieves hyper-cheap, abundant energy like commercial nuclear fusion, this becomes completely economically viable. And the fourth high-tech shift is dematerialization. This just means drastically reducing the physical matter needed to generate value in the first place. Think about how a single smartphone replaced your camera, your GPS unit, a physical map, a calculator, and your entire CD collection. As computing shifts heavily into the cloud and we rely more on digital-first physics, the actual physical mass required to deliver utility drops continuously. Okay, let's take a breath. From the cosmic scale of asteroid mining and molecular nanobots, let's bring it right back down to Earth. Because building that necessary bridge to the future starts today, and you have an actionable role in this. The main takeaway here is to pull that old tech out of hibernation and recycle it today. Find your local recycling centers. When you buy new tech, vet the vendor's end-of-life plan. Demand return options from manufacturers so they are forced to actually deal with the atomic assets they produced in the first place. And I'll leave you with this final, provocative thought. Corporations inevitably follow where the people go. If you demand a circular economy, they will build one. We have the data, we have the roadmap, and we know exactly what is at stake. So the question isn't just about what society will do. The real question is, are you ready to get involved? Think about how you're managing your own e-waste today, and let that be the first step in solving this global crisis. Thanks for joining me on this one.